Hi guys, myself M. Chandrapratap Reddy from the Department of Electronic and Communication Engineering, studying in Srinivas Ramanujam Institute of Technology. Today we are discussing about define quality factor and find Q factor of inductor and Q factor of capacitor. Introduction to quality factor. The quality factor or Q factor is a measure of the efficiency and the performance of electronic components, particularly inductors and capacitors. It can describes how a component can store energy compared to how much energy it loses. Define quality factor. Definition. The quality factor or Q factor is a dimensionless parameter that describes how good an inductor or capacitor is at storing energy. It qualifies the ratio of energy stored to energy dissipated in the component. Energy dissipation. The quality factor or Q factor indicates the how efficiency a component can store energy. A quality factor or Q factor means component how loss energy dissipation, while a Q factor means significant energy is lost. Applications. The quality factor is crucial in electronics as it determines the performance and efficiency of the circuits involving inductors and capacitors, such as filters, oscillators, and resonant circuits. Importance of Q factor in electronics. Circuit performance. The quality factor or Q factor is crucial in determining the performance of electronic circuits such as filters, oscillators, and amplifiers. Energy efficiency. A higher Q factor indicates less energy loss, leading to more efficient and stable circuit operation. Precise. The Q factor affects the precision and selectivity of electronic components, allowing for accurate turning and filtering. Q factor of inductor. Definition. The quality factor of an inductor is a measure of its efficiency and energy storage capability. It represents the ratio of the inductor reactance to its resistance. Importance. The Q factor of an inductor is crucial in determining the performance of circuits, especially in high frequency applications such as radio frequency and microwave circuits. High Q factor. A high Q factor indicates that the inductor can store more energy and has lower energy dissipation, making it more efficient and stable for applications like filters, oscillators, and impedance matching networks. Factors affecting inductor Q factor. Wind resistance. The resistance of the wire used to wind the inductor coil directly impacts the quality factor. Lower resistance leads to high Q factor. Core material. The choice of core material such as air, ferrite, or iron affects the Q factor. Cores with lower losses generally results in high Q factors. Frequency. The Q factor of an inductor is frequency dependent. As the frequency increases, the Q factor typically improves up to a certain point. Inductor size. Larger inductors generally have higher frequency Q factors due to reduced winding resistance and the parasitic effects compared to smaller inductors. Calculation of inductor of Q factor. Inductance. The inductance of the coil resistance. The resistance of the coil Q-factor. The ratio of inductance to the resistance. The Q-factor of an inductor is calculated as the ratio of the inductor reactance to its resistance. Specifically, the Q-factor is equals to inductance of the coil divided by the resistance of the coil. This formula allows to qualify the quality and efficiency of the inductor in a circuit. Q-factor of a capacitor. Definition. The quality factor of a capacitor is measured of its efficiency in storing electrical energy. It represents the ratio of the energy stored to the energy dissipated in the capacitor. Factors affecting Q factor. The Q factor of a capacitor is influenced by the dielectric material used, the construction of the capacitor, and the operating frequency. High quality dielectrics and precise manufacturing contribute to a higher Q factor calculation. The Q factor of a capacitor can be calculated as the ratio of the capacitive reactance to the equivalent resistance, series resistance of the capacitor. A higher Q factor indicates a more efficient capacitor. Factors affecting capacitor Q factor. Dielectric materials. The quality of the dielectric material used in the capacitor construction significantly impacts its Q factor. High quality, low loss dielectrics results in high Q factors. Frequency of operation. The Q factor of a capacitor is frequency dependent. It is higher at a lower frequency and decreases as the frequency increases. Capacitor size. Larger capacitors generally have high Q factors due to the reduced resistance losses in the leads, leads and plates. Smaller capacitors tend to have lower Q factors. Mounting and packaging. The way the capacitor is mounted and packaged can impact its Q factor by introducing additional parasitic elements that increases losses. Calculating of a Q factor of capacitor. Capacitance. Measure of a capacitor's ability to store energy or charge. Equivalent series. Resistance in series with the capacitor. Angular frequency. Frequency of the applied signal. The quality factor of a capacitor is calculated as the ratio of the capacitive reactance to the equivalent series resistance at the given frequency. This formula captures the capacitor's efficiency in the storing and releasing energy, which is crucial for filter and tuning circuit performance. Practical applications of Q factor. The quality factor or Q factor is a crucial parameter in electronic design. The design has numerous practical applications. It is widely used to assess the efficiency and performance of electronic components, circuits and systems. High Q inductors and capacitors are essential for improving the selectivity and sensitivity of the radio frequency and microwave circuits, enabling better signal filtering and frequency selection. The Q factor also directly impacts the efficiency of the power electronics, resonant circuits, and energy storage devices. Thank you.